Hello children, welcome to AIMS India's online class session. Today from physics subject, force topic we are going to continue. So our today's concept is effects of forces. Effects of forces. So the force is invisible. We know that the force is invisible. One minute, children. The force is invisible, but the effect of force, we can see the effect of force. We can see the effect of force. So one minute, children. The force itself is invisible, but the effect of force is visible. The effect of force is visible. A force can produce the following effects. So it can move a stationary object. Stationary means the object which is under rest. If the object is under rest, so then the force can create motion in that kind of object, that stationary object. A force can stop a moving object. Already, if the object is moving, if it is in motion, then the force can stop it. Force can stop it. Say a force can change the speed of the moving object. So for the moving object, it may increase the speed, it may decrease the speed. A force can change the direction of a moving object. Or a force can change shape or size of an object. So here, actually what is force here? Force is nothing but it's a kind of push or pull. So with the push or pull, we can do these many things. All these things are possible. So all these types of things are possible. We can move a stationary object, or we can stop a moving object, or we can change the speed of moving object, direction of moving object, shape and size of the object. So here, so actually, so the push or pull on an object is called force. Like a car being pushed by the man is an example of force, because of which car will move. So a girl pulling the chair is an example of force, because of which the chair will move. So force comes into play due to interaction between the objects. So here, interaction between the car and person, interaction between the chair and girl. So because of the interaction of two objects, force comes into play. Suppose here, so here tire, the boy is with the help of stick, he is trying to move the tire. So what happens? The state of motion of tire makes it to move faster. So with the stick we will beat the tire, the speed of the tire will increase, the state of motion of the tire will increase. So here the box is under rest. If the person tries to pull the box with a greater force, so it starts moving. So means it can change the state of rest or state of motion of a body. So here force applied on this dough means chapati. For making chapati, we will make use of this one, wheat flour. So that after mixing it with water, it will become like this. So we can apply force by our hands to change its shape. Or suppose if you have a rubber band, we can change the size of the rubber band by pulling with our fingers. So force can change size or shape of the body. So let's learn about one by one in detailed manner. So a force can move a stationary object. Suppose here the ball, before hitting by the boy, the football is in rest position. So by hitting the ball with the leg, because of interaction of the leg and the ball will be starting moving. So means a stationary object which is under rest will start moving because of the force. Here what force? Pushing or hitting force, or one kind of muscular force. By one kind of muscular force. So here two persons trying to push another person who is sitting on a tricycle. So first girl, force of the girl is F1, force of the boy is F2. With force F1 and F2, they are trying to move the other girl who is sitting on tricycle. So with what force they will move? With 7 newtons plus 10 newtons, altogether with 17 newtons force. 17 newtons force, they will move the stationary object. Here the stationary object is tricycle, or the girl sitting on the tricycle. So here interaction, here one interaction is there, here another interaction is there. So we have to calculate total force. So in this second case also, we can observe movement in the stationary object because of combination of two forces. Here only single force was involved, here two forces are involved. Or with the stick, we can move the tire. So before movement, it was under rest. By hitting with the stick, we can create motion in the tire. So a force can move a stationary object. So next, a force can stop a moving object. So here the goalkeeper is trying to stop the ball. The goalkeeper is trying to stop the ball or opposing the ball such that it cannot go into the goal, because his opposition team, his opposition team, 1 minute children, his opposition team might have hit the ball this side. So instead of if it goes into the goal, the opposition team will get 1 point. So that's why this person, goalkeeper is trying to stop the ball. It is not allowing to go into the goal. So already here ball is, it's a moving object. Here the goalkeeper is using the force to stop the moving object. Or here this boy, he is an hockey player. He is trying to stop the hockey ball. Because suppose if the ball is coming from here, what he will do? He will try to stop it first. He will take the direction, then he will hit in another direction. So the hockey player is trying to stop the hockey ball. Or cricket, this player is standing on the 4 line. So if he leaves the ball will go here and the team will get 4 runs. So what he is doing? He is trying to stop the ball with his hands. So here, if you take the example of football or hockey ball or cricket ball, all of them, they are in what? Initially they are in motion. So after stopping, now they are under rest. Means a moving object can be stopped. How? By applying the force. Okay, next. Here. Next. So a force can change the speed of a moving object. Speed of a moving object. Suppose if a batsman, if a batsman hits the ball with bat, speed of the moving ball changes. It may go into the field. He may get 2 runs or 4 runs or 6 runs based on the type of force he is using. So like Dhoni, if it is a helicopter shot, Dhoni's helicopter shot, so what happens to the ball? It will be a 6. Means it depends on force. It depends on force with which we are hitting. Because as Dhoni is hitting the ball with greater force, the ball is going to a greater distance and he will be getting 6 runs. Or when a person applies brakes in car, suddenly the car comes to rest. Means when it is moving, its speed is somewhat fast or speed is more. But when it is under rest, speed is becoming 0, or the vehicle is initially slowing down and finally coming to 0. So okay, means a force can change the speed. Or when a fielder catches the ball, the speed of the ball will decrease. Or suppose we have a trolley. If you pull the trolley, we have a trolley here. If you pull the trolley, what happens? The speed of the trolley will increase. So a force can change speed of the moving object. So next. A force can change direction of the moving object. So in the game of cricket, the bowler is bowling the ball. The ball is coming from in this direction. When before hitting or what we can call before applying force, the ball is coming in this direction. But what the batsman will do? The batsman will hit the ball. Batsman will hit the ball in this direction. So the ball is going in this direction. Suppose it is coming with speed. It is going with some speed. But not only speed here, the direction of the ball also changing because of the force used by the batsman. Or if you take the example of carrom board, here you are having striker, here you are having coin. Suppose from here, with the help of striker, if you hit the coin, what happens to coin? Coins may go in this direction, striker may go in this direction, but you are hitting in this direction. But after hitting from here, because of interaction of this striker and coin, because of this interaction, the striker may go this side, coin may go this side. So the direction of the striker and coin both changes. Because of the force. So next, a force can change the shape of an object. So here a force can change the shape of an object. So if you squeeze lemon, so initially it was in a round shape. Initially the lemon was in, suppose if it is in round shape. So after squeezing, its shape will become irregular. Means a force can change the shape of an object. Or if you try to compress if you try to compress a bottle, sorry, cold drink tin. If you try to compress a cold drink tin, one minute, children. If you try to compress a cold drink tin, so it will be crashed. It will be crashed like this. It will be crashed like this. So by applying force, we can change the shape of an object. Shape of an object. So next. So not only shape. So here, by applying force, we can change the size of an object. Suppose if we have a spring, if we have a spring, if I apply force, in this, from here and from here, from this side and from this side, if from both sides, if I try to stretch the string, so the string will elongate. Elongate means the length of the string will increase. So a force can change size of the object, as in the case of spring. Or if you have a ball, if you have a rubber ball, if you press it, if you apply force from this end and this end, from both ends, its size will decrease. Its radius will decrease. It may, circle shape may become ellipse shape, and its radius will decrease. So a force can also change the size of an object. So next. But whatever change happened in the objects, let's see whether they are permanent or temporary. Temporary change, permanent change. Here, stretching a rubber band. If you remove the force, what happened? It will comes to the original position. So it's a temporary change. Means up to one limit. You can stretch it. It will come back to the original position. Temporary change. If you use force greater than the limit, what happens? It may break. Or squeezing the sponge. It's a temporary change. So sponge means, while washing the car, what we will do? We will dip in water, surf water, and we can wash the car. So by squeezing, we can, while washing, we can squeeze it and wash, but after some time, it will come back to the original position. Okay. So it's temporary change. Tearing paper. Suppose if you have a paper, you tear it into two pieces. Means it's a permanent change. We cannot attach the two pieces together again without any external help. So by themselves, they cannot be attached. Here, sponge means by itself, it can come back to its normal position. Here, sponge means by itself, it can come back to its normal position. But the paper pieces, by themselves, they cannot come back to the original position. Or crushing a plastic bottle, it's permanent, because it's not elastic. It's a plastic bottle. We cannot come back, make it into normal shape again. Or making chapati, whatever wheat flour is there, we can make it into desired shape. Whatever shape you want, we can make it into that shape. It's a temporary change. Breaking a glass, permanent. So actually, making of chapati also, by itself, it cannot come back to its original position. So in that way, if you think, means it is permanent. But if you apply force, we can make it come back to its original position. Okay. So some changes may be permanent, some changes may be temporary. So next. So change in the effect of force with area of contact. Change in the effect of force with area of contact. Suppose here a person is trying to keep a hole on the wall with the help of hammer. With the help of hammer, he want to make a hole in the wall with the help of hammer, and for that he has taken the help of one shape called dumbbell shape. With the dumbbell he is keeping here and he is trying to hit with the hammer. He tries to make a hole with the dumbbell and hammer. Is it possible? No. Ouch. Means it's not possible. It's very, very, very difficult. But instead of dumbbell, same wall, same size of hole, same person, same hammer. Instead of dumbbell shape, if he takes a nail, now can he make a hole? Yes. Now he can make a hole. So yes, now he can make a hole. What is the difference? Because the force is acting between the interaction of the force will be because of interaction between two objects. This is the dumbbell, this is the wall. This is the wall. Here area of contact is more. So that's why force is less. So that's why we are not able to make a hole. But here if you compare the nail and the wall, the area of contact is very, very, very less. So force will be more, or we can create a hole. Means though we are making the same effort, but here force is less, here force is more. Means force also depends on area of contact. So now, if you press the arm with your palm, so you can experience less force. But if you press the palm with finger, then you can feel more force. One minute, children. 1 minute. So then you can feel more force. So when you press with your palm, you can feel less force. When you on the same place, on the same spot, if you press with your finger, you can feel more force. Why? Means when you are pressing with your palm, area of contact is more. When you are pressing with your finger, area of contact is less. So we can prove that force depends on area of contact. So next, here, when you try to press on your palm with the sharp end of the pen, or with the blunt backside of the pen or pencil, with the front side of pen or pencil, back side of pen or pencil, if you try to push your palm, from the back side, you can experience less force. From the front side, you can experience more force. Because front side, area of contact is less, force is more. Back side, area of contact is more, force is less. So, okay. So here force depends on. So here we have learnt about a new concept that force depends on area, that force by area that ratio is called pressure. That ratio is called pressure. Means how much force we are applying and on how much area we are applying, that ratio is called pressure. So with the help of force, they have developed a new concept called pressure. So pressure means force by area, and unit of pressure is force area is newtons, area units are meter square. So unit of pressure will become Newton per meter square in complete words, or in symbols N by m square also we can write. N by m square also we can write. Suppose here. Next. Suppose here this block kept on wooden block. So here wooden block area is more, or area of contact is more. Force F1, here also force F1, but here area of contact is A1, here area of contact is A2, as A1 area more than A2 area. That's why P1 pressure will be less than here. Suppose here pressure is P1, here pressure is P2, area is more, pressure will be less. Area is less, pressure will be more. When the forces are same, F1 equal to F1. In both conditions forces are same, but areas are greater. So pressure will be less. More area, less pressure. Less area, more pressure. Less area, more pressure. So like that we can learn about pressure. So identifying the pressure. So if in one box, if you, 1 minute. So in one box you are taking some sand in first box, same amount of sand in second box, and you have taken rectangular bricks. Both are having same size, same shape, or same dimensions we can call, or same mass. Means both of them are identical. Both of them are identical. So identical bricks. We are taking identical bricks. We are taking identical bricks. Okay. So both, here also same brick, here also same brick we have taken, and we are keeping them on the, or in the box containing the sand, such that this surface is in contact. Here this surface, suppose it is A1 surface is in contact with the sand. Here only this surface, A2 surface, means A1 surface is more surface area in contact. A2 is less surface area is in contact. If we keep the bricks in the sand, so after some time the bricks will go deeper into the sand. So now the question is, which one will go deeper? Because both are having same size, shape, dimensions, mass. So both of them apply same force. Here also F1, here also F1 on the sand. But which one will go deeper? So this A2 area contact will go deeper. Why? Means less area of surface is in contact. So more pressure. So it will go deeper into the sand compared to A1. Why? Means A1 is having more surface area is contact. So it will go to less depth. Next. So difference between sharp knife and dull one. Dull knife, or you can also call it as blunt. Sharp opposite word is blunt. Blunt knife. With the sharp knife, we can cut the tomato easily. Why? Means for the sharp knife, the area of contact is less because it is very, very sharp. We can cut the vegetables easily. Whereas with the blunt knife, we cannot cut the vegetables easily, as we have done with sharp knife. or we have to apply more force. So from the force concept, we can also understand the concept called pressure. So what we have learned today, children? What we have learned? So effects of forces, it can move. Effects of forces we have learned. Force comes into play due to interaction. It can move a stationary object. It can stop a moving object. It can change the speed of a moving object. It can change the direction of moving object. It can change the shape. It can change the shape of an object, size of an object, but the changes may be temporary or permanent. Or when force is considered along with the area of contact, then we will learn about new concept called pressure, which is defined as force by area. Its unit is Newton per meter square. More area of contact, less pressure. Less area of contact, more pressure. So with the examples, we can understand that phenomena of pressure. Okay, children, that's all for today. So thank you for watching our video. Please subscribe our channel and press the bell icon for receiving latest updates. Thank you. Have a good day.